Welcome back. So in this video, I'm going to finish the question 4, 5, and 6 from this year's Specialist Maths Exam 2. So question 4 is basically a logistic equation problem. So a fish farmer releases 200 fish into a pond that originally contained no fish. So this is the initial population. P naught equals to 200. The fish population P grows according to the logistic model. The P dt equals to P times 1 minus P over 1,000. T is the time in years, and P naught is 200. So the above logistic differential equation can be expressed as an integral equation. Basically, if we were to use the by hand approach, we need to flip over the differential equation. So you get a dt dp equals to 1 over P minus P times 1 minus P over 1,000. Basically, the next step is to integrate both sides. And you can cancel out the dp's. Well, you don't really cancel out like a fraction part, but you will get an anti-deriving 1 times dt eventually. So the next target is to decompose this partial fraction. Well, I would say 1 over P 1 minus P over 1,000 equals to some constant A divided by P plus B over 1 minus P over 1,000. So you may want to use CAS calculator to decompose this partial fraction, but what I'm going to do is 1 times 1 minus P over 1,000 times A plus B times P equals to 1. So then you can choose P equals to 1,000. Therefore, 1,000 B equals to 1. B equals to 1 over 1,000. Similarly, you get P equals to 0, sub into the equation for equating the numerator. And you get A times 1 minus 0 plus 0 equals to 1. So A equals to 1. Therefore, A equals to 1. B equals to 1 over 1,000. I guess one misconception when you use your CAS calculator is writing an incorrect value of B. For example, I can show you what's happening with the CAS calculator. If you use expand and a fraction, 1 over P times 1 minus P over 1,000, comma P. You can actually see this is the minus here, and it's P minus 1,000 rather than 1,000 minus P. And also, you probably need to divide both numerator and the denominator by 1,000 to get 1 minus P over 1,000. And probably a student may have written down -1 or 1 or whatever. So just be very careful. Okay. The next thing I'm going to do is to show you the desolve button. Actually, I didn't use the integral method to solve this differential equation, and the question didn't ask for some process to show a solution. In the second part, it just tells you some certain form of the solution for P in terms of T. So what I'm doing is desolve P dash. P dash means the P dt, the original derivative, equals to P times 1 minus P over 1,000, comma T, comma P. So basically, this will give you like 1,000 ET over ET plus 1,000 times C1. So this is like an integration constant. But well, basically, you can divide the top and the bottom by e to the power of t. What I'm going to do is I will incorporate the initial condition by typing space and space. P of 0, close bracket, equals to originally 200 fishes in the pond. So this is the particular solution. And if you divide everything by e to the power of t, there will be an e to the, let me show you, e to the power of minus t. So this is true. That's why your d value is going to be 4, okay? And The next part of the question tells you an equation of Q equals to 1000 over 1 plus 9 exponential minus 1.1t. So basically, T is the year after the N fish are released. So if you substitute T equals to 0, you would basically get your N value, which is 100. But make sure you answer the question using N rather than Q, because the letter we are looking for in the exam question is N rather than Q. And then we can just sub in T equals to 6. The question says you probably need to round the Q value correct to the nearest integer. Okay, so that's the first 4 easy marks. Just be very, very careful. Okay, N equals to Q naught equals to 100 fishes. Okay, find the value of Q when T equals to 6. So Q6 equals to 987.9 something. All right. Next thing, given that the QDT equals to 11 over 10Q times 1 minus Q over 100, express the 2Q dt squared in terms of Q. So this is a typical parametric differentiation or implicit differentiation problem. What I'm saying is the 2Q dt squared. Well, a misconception is differentiating just with respect to Q. But remember, you still need to multiply by an extra dq dt. Okay, so because dq dt equals to 1.1 q minus q squared over 1000. The first bit here is 1.1 times 1 minus 2q over 1000. Don't forget to multiply by q dt itself though. So 1.1 times q minus q squared over 1000. We tidy up with this expression a little bit. So 1.1 squared is 1.21. And the first bracket is 1 minus q over 500. Second bracket though is take out a q, get 1 minus q over 1000. Okay. The question didn't have a fixed required form, so I think anything equivalent to this last line would have been accepted, I suppose, but I'm not sure. So you probably want to check this with your CAS calculator. The most important thing is to multiply dq dt rather than just leaving this bit in terms of q only. Okay. Hence, or otherwise, find the size of the fish population in pond 2 and the value of t when the rate of growth of the population is a maximum. Basically, the rate of growth of the population is a maximum when the second derivative equals to 0. But the first derivative is not equal to 0 because it's not a stationary point, it's just a point of inflection. So what I'm trying to say is this bit cannot be equal to 0, but just this bit. So we can see q equals to 500. And also 500 equals to Q of T. Well, we have already used the expression for Q in terms of T, so we can just use our CAS calculator to see what's going on. All right, so we can use solve button. Want to find T? Set that to 500. 20 natural log 3 over 11, but we want the T value correct to the nearest year, so Control Enter. 1.997476 something. 3.8, very lucky number. But we just need to write T equals to 2, okay? The nearest 2 years, okay? All right. And the next part, I suppose. Next part, we want to sketch the graph of Q versus T on the set of axes below. Want to label any axis intercept and any asymptotes. It doesn't ask us to find to state the coordinates of the point of inflection, but we already obtained is roughly 2 here and 500, exactly 500. Okay, so I probably would label a point like 20 over 11 log e of 3 comma 500. Of course, if you label 1.997 something 500, well, it's not required, so you don't need to label that, but you have to get an accurate position. Like this is a special feature of the logistic graph. So it's a point of inflection here. Starting point is 0, 100. Well, you need to use a ruler because it's a horizontal asymptote. Okay. Now, let's just use blue color to emphasize everything. But on the physical paper, you are more than encouraged to use pencil. And we know at t equals to 6 from previous part, we know it's roughly slightly below 1,000, roughly here, I guess. 6,987.90. Okay, so now we carefully sketch something like this. And this, well, you probably need to show some good curvature, okay? Good curvature. And it's not just stopping at 6, so we need to extend beyond that point, okay? And is that everything? I suppose you need to label the equation. Q equals to 1,000, okay? All right. The farmer wishes to take 5.5% of the fish from pond to each year. The modified logistic differential equation that would model the fish population Q in pond 2 after T years in this situation is now the original one subtracting 0.055 Q. So the maximum number of fish that could be supported in pond 2 in this situation is basically looking for the QTT approaching to 0. So we will put the whole thing equal to 0 in our CAS calculator and try to find a Q. Well, the Q value must be greater than 0. So this is looking for the horizontal asymptote is what? Okay. Now, you probably can just take the limit of this t approaches to infinity, okay? That will also work. But actually, I kind of just use this equation because it's from the unmodified differential equation. So let's just do solve 1.1 Q times 1 minus 0.001 Q, subtracting 0.055 Q equal to 0 Q. Q equals to 950. So that's the maximum capacity of this pond, okay? Right. So basically that's question 4. And let's have a look at question 5. Okay, question 5. Very lovely vector lines and planes analysis question. So the points with coordinate A, B, and C all lie in the plane pi. Find that vectors A, B, and AC, and hence show that the area of triangle ABC is 1.5 square units. So A to B is vector B subtracting vector A, OB minus OA. So 1 minus 1 is 0, I. 2 minus 1 is 1J, and 3 minus 2 is 1K. And A to C is OC minus OA, so 3 minus 1 is 2I, 2 minus 1 is 1J, 4 minus 2 is 2K. And hence show that the area of triangle is 1.5 square units. So basically, I'm thinking about a cross product, because if I'm doing A, B, C, finding the magnitude of this perpendicular and vector n, the magnitude of this n here is the magnitude of the area for this parallelogram. If I halve this area, I'll get an area of triangle. So let's do AB cross AC. Well, because we are in a tech active environment, I probably would just go for, let's say, CAS calculator. All right. Let's just do AB is assigned to 0, 1, 1. AC is assigned to 2, 1, 2. So cross P, AB, AC gives me 1I plus 2J minus 2K. And then if I take the norm, that's 3. So that's the area of the parallelogram, and it's going to be a 3 over 2. Okay, so to properly show everything, I would say I probably would include some working here, because it's a show that question. And that gives me 1, 2 minus 2. So area parallelogram is magnitude of AB cross AC. 1 plus 4 under the square root, which is 3. Therefore, area of triangle is half times 3, which is 1.5 square units. Okay, now the shortest distance from point B to the line segment AC. Let's simplify this model a bit. So if I have an A here and C here, I also have a B here. Well, what I'm trying to do is I need to find a perpendicular distance from B to the line AC. What I'm trying to think is probably perpendicular resolute. This is the most familiar concept in my head immediately. So let AB equals to U, which is 0I plus 1j plus 1k. A to C is V equals to 2i plus 1j plus 2k. So use perpendicular resolute formula. U perpendicular to AC, U perpendicular to V is U subtract U dot V hat. Dot V hat. So I'm going to calculate this vector and then find the magnitude of this perpendicular resolute. Let me just highlight this with my orange color. So that is the thing we want to find. The vector quantity, then its magnitude, okay? So what I can do is AB minus dot P, AB unit V, AC times unit V, AC. So basically I can get a minus 2 over 3, 2 over 3, and 1 out of 3. And then I take the norm. So the shortest distance is basically 1. Okay, so let's get back and write down this working and answer. Basically, you square everything, add up, and take the square root. 1 unit. Of course, there are other ways. For example, like in one of my previous video, I actually discussed this model. Like you take the cross product between AB and the unit vector AC. It also works, okay? I suppose this is like AB cross AC magnitude divided by the magnitude of AC, okay? Something like that. So from previous part, it was like 3. I already calculated that. And the magnitude of AC is basically root 4 plus 1 plus 4. Whoa, exactly 1, okay? So this is another possible way. I guess there are so many possible approaches to the second part. Let's just move on to have a look at the remaining. So for the remaining parts, now we are talking about the second play. This is called a Greek letter phi, okay? Capital Phi has a Cartesian equation 2x minus 2y minus z equals to minus 18. So at what acute angle does the line given by RT intersect the plane phi? Give your answer in degrees corrected to the nearest degree. So if you think about the plane, this is a phi. It has a normal vector. The normal vector is going to be 2i minus 2j minus 1k. Imagine you have a line intersecting at this point. Now, the direction of this line is like the vector after this parameter t, 1i minus 2j plus 2k. So what I'm saying is this vector, I already used the letter v, so let's just call this, should I say d, or let's just call this v, okay? Equals to 1i minus 2j plus 2k. So the geometry is we can use the dot product between n and v to find this angle, but what we actually want is the angle between the line and the plane. So this is theta, and the angle we use dot product to find is actually half pi minus theta, okay? I'll write it clearly, half pi minus theta, okay? Just be aware of that. So when you set up the equation, it's like n dot v equals to magnitude of n, magnitude of v. cosine of half pi minus theta. Well, actually, because I want to find the degree answer, I can just say 90 minus theta degrees. Okay, so n dot v is like a 2 plus 4 minus 2. Magnitude of the first bit is going to be square root of 9. Magnitude of the second vector is also square root of 9. Cosine 90 take away theta in degrees. So I'm going to solve this equation. For example, 4 equals to 9 cosine 90 minus theta degrees. And see what I get. Because I put a degree sign here, I just need to use 0 to 90 rather than 0 to half pi because it's looking for an acute angle. So the answer is going to be 26.38 something. Nearest degree, that would be 26 degrees, okay? Okay. A line L passes through the origin and is normal to the plane phi. The line intersects phi at point D. So if it passes through the origin, it will contain 0, 0, 0. If it's perpendicular or normal to the plane phi, we can share the normal vector as its direction vector. So basically, we want an equation of line L in parametric form. Well, we know the vector equation is RL equals to 0i plus 0j plus 0k plus, let's say, some parameter s times vector n, the direction vector. The reason why I'm not using t is because in the previous equation of the first line, it already used the letter t. I don't want to repeat the letter. It must be another parameter. And also, this is a line extending two directions. So s is a real number. Now, the question was, well, an equation. I probably would treat this one as a set of 3 parametric equations. So x is going to be 2s. Y is going to be 0 plus minus 2s minus 2s. And z equals to minus s. Parametric equations. And find the shortest distance from the origin to the plane phi. So basically, if I'm talking about, from the origin to the plane, I could just, apply a formula. So, okay, let's say distance from origin, let's call this one, actually it's intersecting D here, OD. OD equals to, this constant take the magnitude divided by square root of 2 squared plus minus 2 squared plus minus 1 squared, okay? So basically, this is a handy formula from Cambridge textbook. Well, Jacaranda textbook has a similar formula, okay? And then you will get plus 18 divided by 3, which is 6 units. An easy 2-mark question. Of course, you could also use, for example, you can pick any point along the plane. Let's say x is 0, y 0, z is 9. And you find, for example, oh, they already used A. So let's call this OP, all right? OP is going to be 0i plus 0j plus 9k. So the distance is actually the vector resolute of OP onto n. And take the magnitude. You will get like 9 times minus 1. Is that 9 times minus 1? Hold on a second. What's the vector n here? Actually, yep. We'll give you the same answer, I suppose, but yep, I may try this method another time, but let's just look at the last one. Find the coordinates of the point D. Okay, so I've got 3 parametric equations. Yep, and let's try this. Two x minus 2y minus c equals to minus 18. Sub everything, you find a constant s. 4s plus 4s plus s equals to minus 18. So 9s equals to minus 18. So s is going to be minus 2. Now, coordinates of D, well, you can just chuck in this x and y, z. So minus 4, 4, 2. Okay? And actually, because, for example, if this is phi, this is the origin. This is D. Actually, we can find the vector length OD here. So OD is going to be square root of 16 plus 16 plus 4. That's root 36. And that is 6. Actually, this is the answer to part E as well. Okay. Nice. All right. I probably have one last question to go through. Let's have a look at question 6. A forest ranger wishes to investigate the mass of adult male koalas in Victoria Forest. A random sample of 20 such koalas has a sample mean of 11.39 kilograms. It is known that the mass of adult male koalas in the forest is normally distributed with a standard deviation of 1. So x bar equals to 1.39. Sigma population standard deviation is 1. N equals to 20. Sea level is 95% or 0.95. So what I'm going to do is use a calculator and let's see, menu, statistics, confidence interval, z interval. Choose stats. Sigma is 1.39 for x bar, 20 koalas, sea level is as it is, 0.95. Press Ctrl Enter, 10.95, 11.83. Just be careful using normal rounding, okay? Don't round down because this is an 8 here. You need to round up, but it's an open circle anyway. according to VCAA formula sheet, right? Of course, you may want to use, for example, Casio. You may go to statistics, calculation, interval, one sample Z interval, choose variable. Next, C level is 0.95, sigma is 1, X bar is 11.39, and N value is 20. Press next. Yep, pretty much the same thing, okay? And it gave you 6 decimal places. Pretty good. All right, so then we move on to the next part. Okay. So the next part is going to be, okay, 60 such random samples are taken and their confidence intervals are calculated. In how many of these confidence intervals would the actual mean mass of all adult male koalas in the forest be expected to lie? So this is basically asking, okay, if we have 60 confidence intervals, the confidence level is 0.95. So I suppose that's 54 plus 3, 57 confidence intervals. Are expected to capture the population mean. Okay, if I were to interpret this question, but I think the question is just looking for the number 57 here. So the next thing is the ranger wants to decrease the width of the 95 confidence interval by 60%. So the 95 confidence interval, originally we used n equals to 20. If I want to decrease the width of confidence interval, let's think about the margin of error. So the margin of error is Z times sigma divided by root n, okay? Something like that. So the first margin of error is Z is 1.96 something. Standard deviation is sigma. And that was 20, okay? Now, decrease by 60% means 40% left. So the second margin of error is like 40%, which is 40 over 100. Let's just write 2 out of 5 times margin of error 1. So it's going to be Z times sigma divided by 20 times 2 over 5. So I'm trying to push these 2 over 5 into the square root and see what new number in the square root. And that will be my, new sample size. So I may just write this as Z times sigma divided by root 20 times 1 over 5 over 2. Okay, so root 20 times root 25 over 4, because I want the same structure. And then 24, cancel down to 5. 5 times 20, 25. 125. So that is Z times sigma divided by root 125. New sample size. N2 equals to 125 koalas. And that is the answer, I believe. It is thought that the mean mass of adult male koalas in the forest is 12 kilograms. So that's something we believe. Always the null hypothesis, mu equals to 12. The ranger thinks that the true mean mass is less than. Okay, so the alternative hypothesis will be mu less than 12, okay? compared with the population mean, or we believed. This 11.6 is not mu, it's X bar, another sample mean value, okay? This is another sample, n equals to 40. So for the rest of the question, if we were to carry out an hypothesis testing for the population mean, we gotta use X bar and n. The ranger decides to apply the one-tailed test at a 1% level of significance and assumes the mass of adult male koalas in the forest is normally distributed with a mean of 12 and a standard deviation of 1. Find the p-value. Well, p-value is just probability of X bar less than or equal to 11.6, given that mu equals to 12. Of course, we need to use a sigma X bar, which is 1 over square root of 40. It's no longer square root of 20. And using your CAS calculator, let's have a look. Okay, go back. Distribution, norm CDF. Lower is minus infinity, I suppose. Upper is gonna be 11.6. Sigma is 1 over square root of 40, close bracket. Mu value is 12. Oh, this is 5.706 times 10 to the power of -3. Probably I just need to move the decimal places by 3 times. So I'm guessing this is 0.005706 something. Let's try the TIN spot though. Actually, yep, that's a valid way. We can also do statistics, stat test, z test, which is stats. Mu naught is 12, sigma is 1, X bar is 11.6, n is 40. We want less than. Control enter. Yep, 0.005706 something. Yep, pretty good. Okay, let's move on. Just need 4 decimal places, so 0.057 4 decimal places. Next thing is draw a conclusion about a null hypothesis in part D from p-values. So because p-value is 0.005706, etc. But it's less than 0.01, okay? 1%, not 5%. We get so used to 5%, but just read the question very carefully. So reject H naught in favor of H1. The mean mass is believed less than 12 kilograms. And that is a conclusion, okay? And what is the critical sample mean? The smallest sample mean for H naught not to be rejected. So if we draw a normal distribution curve like this, the mean value is 12. This is X bar. And we just want this bit. Let me just use another color to make it nicer. We want this area to be 0.01. So this is my alpha, okay? So basically, I would like to find a critical value C star here. So what I'm trying to do is so norm CDF minus infinity, comma, let's call this value C, comma, 12, comma, 1 over square root of 40. So that is the sample mean standard deviation equals to 0.01, comma, for C. So we solved for 11.6 63217. If we use normal rounding, the C star value is going to be the smallest sample mean for H naught not to be rejected, 11.632. But actually, if we think carefully, this value here has so many decimal places. So if we just truncate this bit, the truncated value actually less than the true value, which will lie within the yellow region rather than the white region, because at this line of before, our action is to reject H naught. And after this line, we accept or do not reject H naught. So that answer comes from rounding normally, normal rounding. I guess even if you wrote 11.633, that would have been accepted. I'm not entirely sure, but C star is 11.633. That's a valid interpretation to the question, because if you look at the VCAA exam report in 2018, exam 2, there was a similar question around this issue. I remember that was question 6, and it's also looking for some sort of smallest possible value for the sample mean such that it's not rejected. And I think back then it was 146.51 and 146.52. These two answers were both accepted according to the chief assessor's report. So I think the precedent case could have been applied here. But anyway, let's move on to look at the last two parts. Suppose that the true mean mass of adult male koalas in the forest is 11.4 kilograms, and the standard deviation is 1 kilogram. The level of significance of the test is still 1%. So we want to find the type 2 error probability. Well, I think that's actually, anyway, this one, VCAA actually had some announcement immediately after the exam. So this is actually H1, this is actually H0. So according to VCAA email, all students were awarded a mark. But if the labeling were at the correct positions, we can still use part H to help us understand part G. So basically, I've got 11.632 or 11.633 something. 11.6 2 or 3. So that is the C star, 11.632 ... And before this bit was alpha, okay, under the old curve. After this line, under the new curve with the actual mean value 11.4. This is the mu actual. So this will be your beta, which is the type 2 error probability, okay? Alpha is the probability of committing a type 1 error. So basically, under the new curve here, the standard deviation doesn't change though. Still one out of square root of 40. 1 out of square root of 40. So probability of type 2 error equals to probability of X bar greater than the opposite of the previous range, 11.63217. Given that mu is actually now 11.4. Sigma x bar is 1 out of square root of 40. Actually, to ensure the maximum accuracy level, I quoted all digits, use the unrounded value. So if you use the rounded value, there could be some sort of a wiggle room or consequential allowance here, but I'm just in case, use all digits for the better accuracy. Norm CDF 11.63217, infinity 11.4, 1 out of square root of 40. So the answer here is 0.07100. 3 decimal places 0.071. If you use the, let's say, 3, the answer is slightly less, okay? And if you use the rounded value, correct to 3 decimal places, okay, 0.071, 0.070. Can't omit this 0, or 0.071, okay? So I believe my preferred answer is 0.071. So let's wait and see what examiner report next year will say. Okay, so that is my completed discussion to the immediately past 2023 Specialist Maths Exam 2. Hopefully, hope all of you who will be watching this video find this thing, these explanations somewhat useful for your future teaching and learning. And I will see you all in the near future. Best of luck for the rest of the year, and wish you all a Merry Christmas, festive holiday with your family members and friends, and Happy New Year 2024. Bye.